Good morning. Today is Friday, September 17th, and we are still in our similarity packet on scale factor and dilations. So today especially, we are going to be working with this standard where we're going to look at the effect of dilations specifically, and the effect that it has on two-dimensional figures using their coordinates. So we're going to come up with that rule that we're going to use in order to dilate figures. And we're going to start today by going over homework from last night. And I know for our homework, we did homework 6 on scale factor and dilations. And for A, the scale factor was, the side I chose was 15/6 for a scale factor of 5/2, which matched to this answer. B, we had this rectangle. They said they wanted the new length with a scale factor of 1.2. So our length was 40. And all we have to do is multiply that dimension times the scale factor for 48 inches as our answer. So that one matched with this answer. For C, scale factor, I chose these sides again, corresponding, new to original. It's 5 to 10. So the scale factor was 1/2, which matched to this answer. For answer D, the scale factor was 3.5. And they wanted to know the new base. The base was 10 inches. So 10 times 3.5 was 35 inches. So that one, 35 inches, matched with this answer. For part E, we used these two lines, corresponding lines, to create the scale factor. And it was the new to the original, 6/4, which simplified to 3/2, which is 1.5 as a decimal. So it matched to this answer. This rectangle, they were looking at a scale factor of 0.2, and they wanted to know what was the new width. Well, since the width was 15 inches, we multiply that times the scale factor, and the new width would be 3 inches, which mapped to that one. For part G, scale factor, I used these corresponding sides, new to original, so 4/5. It was already simplified, but we could have converted it by dividing 4 divided by 5 to get 8/10, and that one matched with this one. And then for this one, the scale factor was 5, so I know it was getting a lot bigger, 5 times bigger, in fact. And they want to know the new height. So our height was 12. 12 times the scale factor of 5, our new height would be 60 inches. So it mapped to that one. So hopefully you did okay on this homework. So now what I'd like us to do is make sure you have everything you need. That includes your packet and your notebook and something to write with. For those of you who are quarantined, you know that your packet is in the Google Classroom, and hopefully by this time you were able to print it. But if not, you can just write the examples and notes in your notebook. All right. Go ahead and get our notebook page started. Today is 9/17, and the title of the lesson that we're covering today is Dilations on the coordinate plane. And in your packet, that's going to be student handout 7. And your homework is going to be homework 7. All right. So before we get started, let's talk about some of the things that we discovered yesterday while we were doing our lessons. Well, we discovered that dilations was a transformation that changed size of the figure, but not shape. So it changes size. but the shape stays the same. Changes size, not shape. And I know that it can be an enlargement, or I could also reduce the figure and make a smaller one. I know that the line segments change, but the angle measures don't. That's how come we get larger or smaller figures with the segment changes, but the shape stays the same because the angle measures stay congruent. We call this same shape, different size. We call that similar. So where congruent is same shape, same size, similar is different size. Got that little interruption, but similar figures means same shape, different size. That's different from congruent, because congruent we know means same shape, same size. Now we also learned yesterday that it's the scale factor that determines how big or small our figure gets. So a scale factor is the ratio of the corresponding sides of the figure. So we pick any two sides that correspond. So this is A, and this is A prime. As we can see, that's an enlargement. So when we're choosing corresponding sides, let's say this one is 4 and this one is 7, then I can choose these sides because they are in the same place on the figure. And I can write a ratio. Now remember, the ratio, the form of the ratio, has to be new figure over the original. So in the case of these two triangles, I can say that my scale factor is 7/4. I've chosen corresponding sides and I put the new amount over the original, 7/4. This is in simplest form. If I wanted to, and I know it's an enlargement, if I wanted to, I can convert that and say this is 1 3/4, so 1.75. It has a scale factor of 1.75. I knew that it was an enlargement because the scale factor was greater than 1. So let's go ahead and add that. Scale factor greater than 1 means we enlarge. Scale factor less than 1 means we reduce. All right, one more thing. If they're asking us to dilate a figure, so to dilate a figure, all we need to do is to multiply each dimension by the scale factor. All right, so this is all the stuff that we reviewed yesterday. Again, as you're watching the video, you can stop, rewind, catch up. So, again, dilations are transformations that are similar, not congruent, because they get bigger or smaller, but the shape does not change. I know we need the scale factor to know how much bigger or smaller it gets, and our scale factor is a ratio. And we need corresponding sides, so we want the sides that match, but we're always going to put the new over the original and simplify if we can. Any scale factor greater than 1 is an enlargement. Anything less than 1 is a reduction. And I know if they want me to dilate the figure, then all we need to do is multiply the dimensions by the scale factor. All right, so let's go ahead and get back in our packet. So we're on student handout 7, dilations on the coordinate plane. So we'll start with the notes at the top. To dilate a figure on a coordinate plane, we need to multiply the x and y values. We haven't discussed that yet, but we will, of each ordered pair by the given scale factor. Now, we've already discussed when we have the image and we can multiply the side lengths times the scale factor to get the new dilated image. But this one is talking about actual points on the coordinate plane, and we'll make that discovery in a moment. But we do know if the scale factor is greater than 1, it's going to enlarge the figure, and if a scale factor is less than 1, it's going to reduce the figure. So let's start with number 1. We can see that there's a quadrilateral ABCD that's already been plotted, and they're going to want us to dilate it by a scale factor of 2. But I decided we're going to do this one a little differently. I have already dilated this rectangle by a scale factor of 2, and I have given you their points. So what I'd like for you to do right now is to, number 1, I want you to place the ordered pairs for the pre-image in your table. And then number 2, I want you to plot the points of the dilated image that I've already given you. So again, I'm going to want you to find the ordered pairs for A, B, C, and D on the pre-image. And then I'm going to want you to go in and plot and label the new dilated points. Stop the video now, and when you're done, turn it back on. Okay, welcome back. So here are the locations of our pre-image points. And we have our dilated rectangle here labeled with prime notation. So go ahead and check to make sure you did that correctly. Now, we didn't discuss it earlier, but they did say a scale factor of 2. So obviously that means that they wanted us to enlarge it. So is what we have an enlargement? Yes. But I guess my next question is going to be is, how can I tell for sure that this new rectangle that I drew is actually an enlargement by a scale factor of 2? Well, we know that if I'm enlarging the figure by scale factor of 2, then each of the dimensions should be 2 times as large, right? So, like for instance, segment BC was 2 units long. If I multiply that by the scale factor of 2, then that means that B prime, C prime should be 4 units long. Is it? 1, 2, 3, 4. Yes. So I do have an enlargement of a scale factor of 2. So I guess we need to figure out, because our goal today is trying to figure out what happens to the points when we dilate. So let's go back to our notebook. All right. So we're doing number 1. And let's look at the points that we had for, let's just do a few of them. Let's do A and B. Can you still see this? Yeah. So let's do point A, which was located at -2, 1. And if you noticed, oh, you can't see that. And A prime was -4, 2. B was located at 2, 1, and B prime was located at 4, 2. Yeah. So the question I have is, what happened to your x and your y value when it got dilated? So if you notice, what do you see happening to the points? What I'm noticing that for point A, it was at -2, the x value, and became -4. And our y value was 1, and it became 2. Well, it looks like what's happening is if we put in our values, so our x and our y value, all that's happening is they're doubling, isn't it? We're multiplying them by 2. Let's see if that works for point B. My x value is 2. If I multiply that times 2, which is our scale factor, I should get 4. Did I? Yes. If I put in my y value, which was 1, and multiply that times the scale factor, I should get 2. Did I? Yes. So what we're seeing is that if you are dilating with a scale factor of 2, then all we need to do is multiply our x and our y values times that scale factor. 2 times 2 is 4. 1 times 2 is 2. Let's see if that same rule applies to point C. Point C was at 2, -1. Our scale factor is 2. So our x value was 2 here. Multiply that times our scale factor. Our y value is -1. Multiply that times our scale factor. And our new location should have been at 2 times 2 is 4. -1 times 2 is -2. Yep, exactly. All right, so all we need to do now is to write an algebraic rule. So remember, we always start our rules by saying x, y becomes. So what happened to our x and our y value when our scale factor was 2? All we did was we multiplied each one times the scale factor. So I know we're going to multiply the x and y values by the scale factor. All right. So let's look at number 2. And we're going to do this one. We're going to start by writing the ordered pairs for the pre-image. So let's find the location of point E, F, and G. Turn the video off and turn it back on when you're done. Welcome back. As you can see, our pre-image points are located here. And according to the instructions on dilating by a scale factor of 2/3, what can we expect to happen to our pre-image? An enlargement or a reduction? But yeah, this is definitely a reduction, right? Because it is less than 0. So now what we need to do is we need to find out what the image points would be. If you would rather turn the video off and do it on your own now, you can. But I will go ahead and guide you through at least one of the points. So let's go into our notebook. So we're going to be doing number 2. And don't forget, all we need to do is to multiply both the x and y values by the scale factor to dilate. All right, so here's our points. Point E was at 3,3. Point F was at 3,9. And point G was at 9,3. And I know that I'm going to multiply my x and my y values times the scale factor. and the scale factor was 2/3. So I'm going to do 2/3 times my x value and 2/3 times my y value to get my new point. So let's do point E. Our x value is 3, and we're multiplying that times 2/3. So 2/3 times 3. And our y value is 3 also. So 2/3 times 3 here also. So we're going to go ahead and multiply these fractions. Pre-simplify, 3 divided by 3 is 1. 3 divided by 3 is 1. So when I do 2 times 1 is 2. And 1 times 1 is 1. And I will do the same thing here. So it looks like E prime. So point E prime would be located at 2, 2. Now go ahead and stop the video and dilate point F and point G using the scale factor of 2/3 to find their new location. And also you can write the algebraic rule for that problem. Turn the video back on when you're done. So as you can see, if we multiply the x and y values times the scale factor of 2/3, E prime would be at 2, 2, F prime would be at 2, 6, and G prime would be at 6, 2. Our algebraic rule is xy becomes 2/3 x and 2/3 y. Let's go ahead and plot it and make sure it looks like we expected it to. I know it's a reduction, and I know it should be about 2/3 the size. So let's see. E prime's at positive 2, positive 2. F prime's at 2, 6. And G prime's at 6, 2. All right, so let's go ahead and connect those points. Looks like a reduction to me. Appears to be about 2/3 the size. Let me just make sure. So let's look at this corresponding sides. And we're going to put new over the original, right? And our new one is 1, 2, 3, 4 units long. And our original was 1, 2, 3, 4, 5, 6 units long. And if I simplify that, that is 2/3. So our scale factor is correct. All right, so what attributes of a figure did each dilation change, and what attributes were preserved? Well, I think we've already just seen that the line segments change lengths. So that's what changes. But what about which attributes were preserved? So looking at these triangles again, I know that angle FEG was 90 degrees. And F prime, E prime, G prime, that's the corresponding angle, is also 90 degrees. And I'm not exactly sure what's the measure of this angle, but I know it's acute. And this one appears to be exactly the same size. So angle measures are preserved. All right, for number 4, they want us to record the ratios, and they look, for number 1. So the quadrilateral up here, the rectangle. And they're doing the new side to the corresponding original side for A prime, B prime, and AB. I know that this one here, A prime, B prime, was 8 units long, and AB was 4. So that's actually equal to 2, isn't it? So I would like you to do the rest of the segments, corresponding sides. Find the length of the new BC side, B prime, C prime, and put that over the original and see what happens. Turn it back on when you're done. So as we can see, once we've compared the corresponding sides with a ratio of new to original, they're all equal to 2. So what do we notice? The ratios are all the same. And furthermore, equal to the scale factor. Remember, for that one, our scale factor was 2. So we wrote a ratio of the corresponding sides, new to the original, and every single pair had the same scale factor. So when you dilate an image by scale factor, every line gets dilated by the same amount. All right, so let's go on to the next page. Let's enter a few notes up here. Okay, finding the scale factor. When a dilation has occurred, you can find the scale factor by choosing corresponding sides or vertices and setting up a ratio. And I know it needs to be the new figure over the original, or we can also call it the image over the pre-image. All right, now for these next 3, they are giving us the completed dilations on the graph here, on a graph here, and then with the points. And it's going to be our job to discover what the scale factor was. So for number 5, let's look at what happened. Does that look like a reduction or an enlargement? Well, this appears to be a reduction, isn't it? Here was our pre-image and our image of A prime, B prime, C prime. So it looks like it got reduced. So we can already get a good guess of what our scale factor is going to look like. Needs to be less than 1, right? So let's see if we can figure out the scale factor. Remember, all we need is side lengths that are corresponding of new over original. So choose any pair of sides, any corresponding sides, and find the scale factor and write the rule when you're done. Turn it back on after you're done. All right, so I chose AC and A prime, C prime to do my scale factor. And the side lengths were 8 over 16, which reduced to half, so scale factor is a half. Rule was XY becomes 1/2 X and 1/2 Y. All right, now that we've done number 5, let's go ahead and I want you to do number 7 on your own. Turn the video back on when you're done. Okay, so how'd you do? Definitely our figure got bigger, so it was an enlargement. Scale factor was 5 over 2, which was simplified, but I can turn into a decimal as 2.5. So our rule was XY is 2.5X and 2.5Y. So let's do number 6, and we're going to do this one together because we haven't seen one like this before. And we do see the pre-image and the image, and I see that they've changed, but I need to find their scale factor from the points. So what are we going to do here? Well, it's still, okay, so this is what I know. I know that I can multiply the X and Y value of a pre-image times the scale factor, and I should get the image values. But it's kind of hard to know what you're going to multiply -8 times to get -6. It's kind of hard to do that mentally. But I have a few tricks up my sleeve. And since I can use any point I want, I think I'm going to choose point R for obvious reasons, because everything was positive, so why not? So point R is located at 8, 4, and R prime is at 6 and 3. So I know at some point I multiplied my X value times the scale factor to get my Y value. So my X value was 8. I know I multiplied that times the scale factor. We'll call that K. And I got this new X value, 6. So 8 times some number is 6. So based on what we did in order of operations the other day, I know that what I could do is, since I'm multiplying, I could do the opposite and I could divide. So that says that K is equal to 6/8. And when simplified, I can say that's 3/4. So we're looking at a scale factor of 3/4. It looks like we multiplied each X and Y value times 3/4 in order to get the new dilated image. So our rule would be XY becomes 3/4 times X and 3/4 times Y. All right, so for numbers 8 through 10 at the bottom, I'm going to ask that you work on your own. You turn off the video, and when you're ready to check your answers, you can turn it back on. Right, so here we are. 5/3 was the scale factor, so X prime, Y prime, Z prime will be larger because 5/3 is greater than 1. Find the location of Z prime. Z was at 9/12. When I multiply each one times 5/3, I get Z prime at 15/20. For this one, it said Max wrote the rule and the scale factor was 5. And they want to know, was he correct? And he was not, because here's our pre-image and here's our image. As you can see, that's a reduction. So a scale factor of 5 is much greater than 1, so it wouldn't be 5. It's actually should have been 1/5 instead of 5. This side is 1, this side is 5. We put the new image over the original, so the scale factor should have been 1/5. And here at the bottom, you have to choose the ones that will give you enlargements. So that would be Roberto and Maxine. Couldn't be Henry because that's a translation. And Ellis was less than 1. So that didn't work. Your homework tonight is going to be on homework 7, dilations on the coordinate plane. Remember, finding scale factor, it's always new over original, and we can dilate points by multiplying the X and Y value times the scale factor. So good luck on your work tonight.